Jai Hind all of you. Myself Deepti Arora. Now we are studying on the topic for flow control and error control, which is in data link layer. That means we are transmitting the data over the data link layer, that is in the form of frames. Now at receiver side, it could be possible that data we are transmitting could be changed. It may have error, or the data we are sending at the from the sender to and received at the receiver side may be out of control at the receiver side. Maybe sender is sender is fast and receiver is slow. It could not manage that amount of data that sender is sending. So how do we manage that data at receiver side? We would study here. For protocols, we are having two types here: noiseless channel and noisy channel. Noiseless channel. Noiseless channel is a channel in which we assume that there is no noise at all. That means no retransmission, no sound effects, and no congestion, no traffic flow at all. So in noiseless channel, there are two protocols: simple and stop and wait protocol. And in noisy channels, we assume that there is lot of traffic, lot of noise, lot of congestion is here. So how data could be transmitted in this position when the channel is too much noisy? We use three protocols: stop and wait, go back and ARQ, and selective repeat. So we will today discuss here the noisy channels protocols, stop and wait. First one is stop and wait protocol. Here I am starting with the noiseless channel of stop and wait protocol, and then we will go further study with noisy channel protocol, that is stop and wait ARQ. ARQ stands for automatic repeat request. So with the stop and wait protocol, with the name it says stop, wait and then send the data. Firstly you have transmitted the frame, then stop for some time, wait and then retransmit the data. Okay. The stop and wait protocol is a flow control protocol. It provides flow control mechanisms that does not provide any error at control mechanism, जिसके अंदर हमें कोई भी error control mechanism देने की जरूरत नहीं है. For example, stop and wait means whatever the data sender want to send, it sends the data to the receiver, and sender after sending the data, it stop and waits until it receives the acknowledgement. The main thing is acknowledgement. It waits for what time of amount? Until it receives the acknowledgement. After receiving the acknowledgement, it transfers the next frame to the receiver. It is unidirectional, in which the sender is sending to the receiver, sending the data to the receiver, and receiver after receiving the frame sends the acknowledgement to the sender. See, primitives are sender side and receiver side. Sender side, sender sends one data packet at a time or one frame at a time, and rule 2, sender sends the next packet only when it receives the acknowledgement. After receiving the acknowledgement only, sender send the next frame. At receiver side, receiver receive and consume the packet. After receiving the packet, receiver sends the acknowledgement to the sender and then waits for the next frame to arrive. See here in this figure, here is the sender, it is having a timeline. It is a receiver, it is also having a timeline. Now sender sends the data packet. After that, it waits, for example, it sends a packet at T1 time. It gets received at T2 time. At T3 time, receiver sends the acknowledgement and it is received here at T4 time. After receiving the acknowledgement from the receiver, the sender sends the next data packet or next frame. This is for the noiseless channel. We are assuming here that there is no change in the data, no error in the data, and receiver can receive the data in a perfect way. Now, disadvantages. What could be the disadvantage here? Lost data. Sender is sending the data, but meanwhile the data could be lost. It could not be received at the receiver side. So what will be did? Sender waits for the acknowledgement for the infinite amount of time. Sender is in the waiting position now. For how long? it is infinite time. Next, now the sender is waiting for the acknowledgement. Receiver has received the data. Now sender is waiting for the acknowledgement. The acknowledgement is lost now. Now what would be the here? The receiver sender waits for the acknowledgement for the infinite time of amount now. Here the receiver is receiving waiting for the data for infinite amount of time because the data has lost, and here the receiver has received the data and sender is waiting for the acknowledgement for the infinite amount of time. What could be the third disadvantage? Delayed acknowledgement in data. After a timeout, a long delayed acknowledgement might be wrongly considered and acknowledgement of some other packet has received. Means the data is received at the receiver side after a long duration of time and it is sending the acknowledgement, and the receiver sender has sent the another data. For example, here the data 1 is sent at receiver side. It could be received at the receiver side. Now receiver received this data at T1 amount of time. Receiver sends the acknowledgement. Meanwhile, it is waiting for the acknowledgement. It could not get the acknowledgement. It again sends the data here, and receiver already sent the data for the previous packet. It assume it is for the next data packet. So here the data packet is different, but acknowledgement is for this one. So this could be a delayed acknowledgement or data, which could be wrongly interpreted as some others data acknowledgement. Now, stop and wait ARQ, automatic repeat request. ARQ stands for automatic repeat request. Now, from the previous we have studied disadvantages. Now these disadvantages are overcome by this stop and wait ARQ protocol. Here stop and wait plus timeout. Timeout for which? Lost data. There at that position, when the sender sent the data and the data got missed, the lost data, sender went for the infinite amount of time, long time for waiting duration. Here we have interpreted here as a timeout. Here we have assumed that after some time that sender will assume that the data packet is lost, it is not received by the receiver, it will retransmit that data packet or data frame. Again, lost acknowledgement. If the acknowledgement is lost, there would be a sequence number for a data. We would put a sequence number in a frame. This is a frame. We will put here some sequence number which could identify which frame the sender has sent. The receiver also receive the packet and send back the acknowledgement of the same sequence number frame. So if the if the acknowledgement or data is missed, then the sequence number of data, with the sequence number of data, we could identify which data packet got lost or which acknowledgement got lost. Then sequence number of acknowledgement, delayed acknowledgement. In case of the acknowledgement is delayed, we would find the sequence number of acknowledgement and then we could retransmit that frame or that data. Okay. How it is working? See, stop and wait. This is the sequence number of a data 010101. We have given the two sequence here 0 and 1. Again 0 and 1. Suppose we are having 10 data packets 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. We are having 10 data packets, and in these data packets we are sequencing. How we are sequencing? 0, 1, 0, 1, 0, 1, 0, 1, 0, again 1. So this would be the sequence of frames of these data packets, sequence number of these data packets or data frames. So we are having a window here. This is the sender side window and this is the receiver side window. This is the timeline at which duration the data packets are sender is sending and the acknowledgement sender is receiving. Here this is the timeline for receiver. Here the receiver receiving the packet and sending the acknowledgement back. So see here, the sequence number is 0. First at the time 1, the start time is started. At time 1, frame 0 is sent. Frame 0 is sent. the receiver window receives the frame 0, it sends the acknowledgement ACK1, acknowledgement 1. That means it is expected the next frame of sequence 1. So it is sending the acknowledgement 1. It is sending the acknowledgement of next expected frame. Now the window moves for 1. Now sender sends again the timer starts here. The sender sends the next frame. Now this frame got lost. Now it is waiting for the acknowledgement. After the waiting timeout has been gone, then the sender again sends the frame 1, resent. After the timeout, then sender sends the frame 1. Now the receiver receives the next frame 1. The window moves to next frame, that is with having a sequence number of 0. So it is sending the acknowledgement for next expected frame, that is acknowledgement 0. Now the window moves to 0, it sends the frame 0. Now again the condition happens, what? Acknowledgement got lost. Now acknowledgement lost. After the timeout, the sender sends the again 0 frame, resent. Now receiver has already received this 0 frame. It is expecting the next frame. So it will discard this duplicate frame and again send the acknowledgement for next expected frame. Now sender got the acknowledgement, it will send the next expected frame, that is having the sequence number 1. So this is the working of stop and wait ARQ protocol, which overcomes all the consequences or all the disadvantages of stop and wait protocol, which we assumed in the noiseless channel. This is for noisy channel where the data got lost or acknowledgement got lost. So how it will work? This will be the main working of stop and wait protocol. Now the next protocol is go back N. Go back N. Here N stands for number of frames. N is the number of frames. That means if the data got lost or acknowledgement got lost, the sender window will send N number of frames again. Again it will retransmit the number of frames to the receiver. Now here what would be the window size? In stop and wait ARQ protocol, we assume that sender and window size would be 1. That means sender will send 1 frame only at that time and receiver will receive the 1 frame only. That's why it is having the sequence number of 0 and 1 only. Here we are expecting that the window size would be 2 to the power m minus 1. That means 2 to the power m and minus 1 is at below. It is the sender's window size. And what would be the receiver window size? It would be 1 as it was in stop and wait protocol. So 2 to the power m minus 1. Now what is m here? M is the size of a sequence number. हम sequence number कैसे निकालेंगे? See, if we are having 10 data frames to be sent, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what would be the sequence number? 2 to the power m. It is for the bit for the sequence number. See how we would do. We are saying that we are having the sequence number for 2 bits. So m here would be 2. We are having the sequence number of 2 bits. So m would be 2 here. So m would be 2. So how many sequence number will be here? 2 to the power 2 minus 1. That would be the window size. So how many sequence number would be there? 2 to the power 2 is 4 minus 1 equals to 3. That means 0, 1 and 2. This would be the window size of go back N protocol. That is the sender's window size in go back N protocol. See here. Consider this situation. When we are having 2 to the power m less than window size, and when we are having equals to 2 to the power m window size, what would be happen? That means we are saying we would have 2 to the power m minus 1. That means this would be the correct frame size, and this would be the condition when we are saying it would be equals to 2 to the power m. What would be the condition here? We are assuming this also. See, this is the sender timeline and this would be the receiver timeline. Sender is having the window size of 2 to the power m minus 1. That is, we are assuming here the sequence number of 2 bits, that is 0001 1011, and this is 2 to the power 4, sorry, 2 to the power 2, this is equals to 4, and we are saying we are having 2 to the power 2 minus 1, that means 3. So this is the window size. This is the gray portion you are seeing. This gray portion, this is the window size, and the sequence number are 0, 1, 2, 3. Now, sender is sending at the frame 0. Acknowledgement for 0 got lost. Now, the window size of sender is big, but the receiver side is small. That is only 1. Sender window size moves to the next frame. That is frame 2. It is sending the frame 1. Then, its acknowledgement also got lost. Again, it sends the next frame, frame 2. Again, the acknowledgement got lost. 0, 1, 2. All the acknowledgement of all the frames got lost. What would be the sender will do? Sender will again send the 0 frame. But it is received by the receiver. So, it will correctly discard that the frame. Now, consider this situation. When the window size is equals to 2 to the power m. That means 0, 1, 2 and 3. Now, sender is sending the frame 0, it got lost. Sender is again sending the frame 1, acknowledgement got lost. Sender is again sending the frame 2, it got lost, acknowledgement got lost. Again, sender is sending the frame 3. Now, also the acknowledgement for frame 3 got lost. All the frames acknowledgements got lost. Now, what would be the situation? Sender has already sent all the frames, but it doesn't get all the acknowledgement. So, sender will again send this frame, that is the frame 0. Now, at receiver side, it has already sent all the acknowledgement, so it is expecting the next expected frame, that is 0. Now, the sender sent the frame 0, it will accept that frame. Why? Because the sequence number is 0 here and sequence number is 0 here. But this was the erroneously accepted. That means the wrong frame is accepted here. It is expecting the next frame, but sender is sending the previous frame which has already accepted by the receiver. So, this would be the situation when window size is equals to 2 to the power m. So, we would consider that we will take the window size that is less than 2 to the power m. So, we are having the window size equals to 2 to the power m minus 1 for sender, and for receiver it would be 1. Now, see the actual working of go back and protocol. See, we have considered the situations, what would be the perfect window size, and we got that window size would be 2 to the power m minus 1. Now, see the actual working. Here we are taking the sequence number for 3 bits. That is 2 to the power 3, which is equals to 8. So, the sequence number is 0 to 7. And what would be our window size? That is minus 1. So, it would be 0 to 6. So, in gray portion, you are seeing the window size, that is 0, 1, 2, 3, 4, 5, 6. That means sender window can send 0 to 6, 7 frames at a time continuously, but receiver window size is equals to 1 only. It could receive only 1 frame at a time. So, now the situation is the sender has started its timer. It sends the frame 0. Receiver received the frame. It sends the acknowledgement for the next expected frame, that is acknowledgement 1. Sender got the acknowledgement. It moves to the next frame, that is frame 1. It sends the frame 1 correctly. Now, the receiver received the frame 1, it sends the acknowledgement, and for the next expected frame, that is acknowledgement 2. Now, this acknowledgement got lost. Now, what the sender is doing? Sender is again sending the next frame without bothering that it got the acknowledgement for the previous frame, because its window size is up to 6. So, it is sending the next frame. It sends the frame 2, it sends the frame 3, again continuously it will send the next frames. Now, see, it sends the acknowledgement of 3, it is sending the acknowledgement 4, but again it lost the acknowledgement for 2. So receiver window will move, but it will not accept those frames. It will move, but it will not accept those frames. What it will do? It has received that acknowledgement of 2. It has received it has sent acknowledgement for 2. That is, it is expecting the next frame 2, but the receiver has not received that acknowledgement. So receiver will, what will it do? After sending the frame up to 6, it will, what it will do? It will resend all the frames from 2. Starting from 2, it will resend all the frames. That is n number of frames. 1, 2, 3, 4, 5. That is n equals to 5. It will retransmit all the 5 frames again, because receiver is not receiving at this side. Its window size is only 1. So it hasn't accepted that 2 frame. So what it will do? It will retransmit all the frames again. Here the situation is that receiver has received the frame 2. So it is moving to the next frames. But what could be the condition if the frame 2 it sends, the sender sends the frame 2 and it got lost? Here the frame 2 got lost. What would happen? At that time, the receiver is waiting for the acknowledgement, but it doesn't get the acknowledgement for frame 2. So it will retransmit all the frames after its window got completed. That means after the window got completed at 6, it will retransmit all the frames starting from 2 to 6. This is the working of go back n protocol. That means go back to the n frames and then retransmit those frames and then move to the next window. Now, see what are the disadvantages of go back n. The main disadvantage is the retransmission of frames. That means the amount of time the sender has sent all the frames, n number of frames, that have taken the bandwidth, that have taken all the processings, but those frames are detected as the corrupted frames. The sender has to retransmit all the frames. So amount of time the sender has used, the receiver has to all get wasted. So it is more time consuming in detecting the errors or the corrupting frames or the error free frames transmitted or not. It is very time consuming. So for this, to overcome all these problems, again we are using the next protocol, that is selective repeat ARQ. Again, ARQ stands for automatic repeat request. Selective repeats, that means it will repeat only the selected frame that got corrupted or that is not error free. It will retransmit only that frame, not all the frames, as we have seen the situation in go back n. It would retransmit only the selected frame here. Now, here the window size is 2 to the power m minus 1 and receiver window size is also 2 to the power m minus 1. That is the same window size. So how it would work? See the situation. Sender and receiver both having the same window size. So it is sending the frame 0, it is receiving the frame 0. Then it is sending the next expected frame acknowledgement, that is acknowledgement 1. Now it is sending the frame 1 which is got lost. So it is sending all the frames in the window. In the sender's window, we are having up to 3. So it is sending the next frame. But at the moving for next window, the receiver has set the negative acknowledgement that it hasn't received the frame number 1. So it is sending the negative acknowledgement for the 1. So receiver has resent the frame 1 and it is now sending the acknowledgement for the next expected frame, that is for frame 4. So the window has moved now to 4, 5, 6 and 7. So this is the working of selective repeat. The sender has sent only the selected frame for which it got the negative acknowledgement. So this is all for the noisy channel protocols. We will meet in the next lecture. Thank you.